Hello, we are going to play in the Python interpreter. Actually, it's IPython version 5.2 and the Python version is 3.5. What we are going to play with is argument packing and unpacking in the function, definition and invocation. It's about functions arguments. Okay, let's start from the simplest function. It's add some number. It's very simple. It's add to number. Serve the purpose of play with the argument packing and unpacking. The just defined function added 1 and 2, it's 3. How we know that it add up the actually it's x and y. Of course, it gave the same result. And let's see the function defined this way. It has argument x and y, and inside the function, x, y live in the function's local scope, namespace inside the function. Outside the function, they didn't exist. So x is undefined, y is undefined, and it's correct. What's about and x equals 2. Sometimes we just come up with the second argument, come up with the y first. It's okay. It means we can call the function, its invocation, call the function with two arguments in sequence. It's a normal way. And we can call it as named parameter, named arguments. It's okay. Simple x. Actually, this is not very simple. Maybe for some programmers. It means let's check what happened inside the function. We add up two strings and we give it as a named parameter, named argument. First, y get a string equals to a string, and x is another string. It just add up the two strings, x first and y follow x, and y is y. Okay, inside the function, it's actually we notice that the operator plus, it can plus number and it can plus operate between strings. Okay, this is why it happens this way, because first plus second it add up, but commonly we didn't need it happen this way. If we omit the plus operator, it still happen. If we omit the space in between and the single quote in between, it still happen. So let's see add up. What about we have a list? It's a list, then we won't give list to the function. No, it's missing one positional argument, but it's interesting because it didn't check the A list, it's a list. If we make it this way, give it another list, it actually add up to list. This is Python. It kind of very friendly. It relaxed the argument. It didn't check its type. It didn't check its type. But we know that our intention is to let it add up the number in this list. So we unpack it. Let's see. We unpack it, use the operator, the star. We are expecting 30. Let's see, 30. What happened? Inside the function, we give it list, but we use the star to unpack the list. So it unpack list to make the numbers inside the list appear sequentially in the position of argument. So it's 10 plus 20. It's get it this way. Okay. A list is 10 and 20. Let's change it. 100 and 200. And call the function unpack the list. We got 300. Yes, it's okay. It's actually, sometimes we do it this way. A equals 1, B equals 2. This is unpacking, somehow unpacking the right hand side. And assign it to the left hand side, and one by one. It's kind of unpacking. And in the function invocation, let's make a tuple. Okay, invokes a function with the tuple, unpack the tuple. We got 88. It happened. It's very good. Okay, what about unpack a dictionary? Because we can call the function as y equals 1 and x equals 2. We got 3, of course. But how to make a dictionary? Dictionary equals okay, x is a string, y is another string. This is a dictionary. We use the dict to form the dictionary. And we can see y is a string, y, x is the string, dot dot x. Okay. Can we, because we can call the function this way, it's 5, okay. Can we pass, somehow use a method to pass the dictionary to the function? We can do it. It's unpack the dictionary and give it. What happened? X, yes, we know x is dot dot x, dot and x, y is y, okay. X plus y. Is the result. Yes, we got the same string. Okay. This is how to unpack a list, sequence data type, tuple, and dictionary to pass it to the function as argument. And let's check the function and make it another way. x, y, z. Give it a default value. I'm default z. Okay, this time we didn't ask it to return anything. Let's see, add up already changed. It get unpacked value of x and y, but z got its default value. We didn't support its default argument, default value for the argument. We can change it even more. Actually, you can use any name for ARGS, but this is a tradition. This makes other programmer know what you are doing. Use ARGS. They know it's an argument list, many arguments in sequence. Okay. This is to unpack the sequence data type. In the function definition, it happened another way. Yes, let's say it. Before we add up two numbers, and this time we want many numbers. 1, 2, 3, 4, 5. Okay, it's a many number. Let's check what happened. It should be okay. Why it take from 2 to 3 positional argument, but 5 were given? What happened? X, Y, and ARGS. Okay, we made an error. We'll forget the column. Yes, after correct the error, we correct it, add up. The ARGS is the rest of the argument we passed to it. And let's see, we make a list. A list range 9. This is the list. We unpack the list to the function, and function will pack it into ARGS. Somehow it happens this way. Unpack more list to it. Yes, the ARGS is, you can see 0 and 1 serve as x and y, and the rest give to ARGS. Okay. And we are going to show how to make any kind of very relaxed argument parsing happen. Okay. X is 0, Y is 1, and ARGS is the rest. Okay. Sometimes we define a function to accept any kind of parameter list, positional and named argument. Anyway, we pass argument to it, it will give us it will accept it. How to define this kind of function? Let's define a function foo ARGS and ARGV this is traditional to name these two arguments. Just the first is argument s, the second is argument v, and we just print it out. Okay. By this way, we can give it any kind of parameter arguments. Okay. Foo is a function. Foo is a function. Let's see. Sum equals sum and others equals anything, and complex equals okay. For accepted, let's see what happened. We can see first it's a tuple. It's some positional argument 2 to 5, and then some named argument, sum, other, complex became the key in the dictionary. Complex, sum, and other. The sequence is changed because it uses internally it uses some kind of hash algorithm to save the key, but they are all there. Okay, let's see what happened in foo. ARGS, it uses a single star as unpacking, a way to unpacking its argument list. It's a list, a sequence data type. We can give it anything in sequence. Then the second is double star. Double star is to unpack dictionary. Dictionary has key and value. List have a sequence of list or tuple have a sequence of kind of data, any kind of data, digit or string. ARGV use double star. It refers to key and value unpacked. So in the function definition, ARGV will be the named arguments and pack it into a dictionary. The dictionary name, the name of the dictionary, of course, it's ARGV, and ARGS is the sequence data type. It's tuple. Inside the function, we can use ARGS and ARGV. Okay. For example, let's print ARGS. Suppose it has the first element. Okay, let's call it. Still, the complex calling. ARGS0 is 2. Yes, we gave it 2. And let's change it. It's 3. Yes, it's 3. And the rest is complex things. It's packed into ARGV, a dictionary. This is pack and unpack. And let's see, add up. I want to feed in a string, unpack a string, because string is also a sequence number. Add up, let's see, string. This is a string. Yes, this is a string. Let's give it to add up. But we unpack the string. Can we do it? Yes. Yes. X is G. It's the first character. Y is O, the second character. We just unpack a string, and inside the function, actually it asks for a sequence of argument. Number is greater than 2 arguments, and it will assign the first to X, the second to Y, and the right to args. Args is tuple. Let's show the type. Okay. And use our string to call it. Do you remember? GG is a string, okay? X is the first, Y is the second, and the type of args is tuple. Args is the rest of the string in tuple already unpacked. Okay. This is we play with the packing and unpacking for function arguments. Okay. And in Python 3 we get annotation for argument. Let's see how to use annotation. Bar will going to show us two argument. It want two argument. It accept two argument. Okay, how to specify it very clear. A give me a int. B give me an int. And I'm going to give you a int. Okay, this is very clear. We can see we use column or semicolon. Column. We use column, give it kind of annotate the first argument A should be int, the second argument B should be int, and its return value should be int. But what's going to happen? Let's see. Bar is a function. Bar 3 and 30. We are going to expect 33, right? Yes, wonderful. But what's happened? Let's use double underline 30. Okay. What? 330. Why it gave us this result? Didn't we annotate it as int input for the first argument and int for the second argument and return int? Yes, it's annotation, just annotation. It means if some programmer read this code, we expect someone, if he's reading this kind of code, this line of code, he knows that we expect a int, two int as import arguments, and we are going to return him a int. But it's only an annotation. So this is why this kind of things happen. It adds up to string and return a string. But still, we got annotation. See, we got annotation. A is int, B is int, and the return should be int. It's annotation only for annotation's sake. Okay. It means in the future maybe the code developers for Python interpreter will apply most strict rules on the annotated code, and currently it serves as annotation, nothing else. Okay, we played with the argument packing, unpacking, unpack the list, the sequence data type. We unpack a list, a tuple, and a string. They all data type of sequence, and we unpack and pack dictionary to a simple function. Okay, just play it inside the interpreter. Python's interpreter. Python is very friendly to programmer, and IPython make it even more friendly. Okay, I'm using IPython. All the example we just saw can be applied to Python or IPython interpreter seamlessly. Okay, thank you. It's all. Bye bye.